Hello Year 5 and welcome to Maths. Let's get started. Oh, sorry. Hope you found somewhere very quiet with your pen and paper. And if you're ready, you can complete the do now. Unpause when you have finished and we'll go through the answers. So how did you do? Let's take a look. This shape has been cut into equal parts. True. I know that it looks a little bit strange, but it's still half of a half, which means that it is 1/4. Number 2, what does this describe? The number of equal parts the whole is split into. That would be the denominator. Number 3, convert 1 3/5 to an improper fraction. That's 8/5. Number 4, convert 7/4 to a mixed number fraction. That's 1 3/4. And number 5, which is the biggest fraction? 1 5/3. How did you do? Good. Okay, so today we're going to add and subtract fractions with the same denominator. Let's just review quickly. What do denominators tell us? Yes, that's right. It tells us how many equal parts there are in total. So when I look at this bar, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 equal parts. What do the numerators tell us? Yeah, how many we are talking about, how many we have. So here we have 1, 2, 3. Great. OK, can you tell me what the denominator of this would be? Tell me. Let's check. Good, 6. And the numerator? 2. Why? Yeah, because they're shaded. Excellent. OK. So the blue rod has the length of 1. Now, we can use this to calculate the length of the red rod. Using the white rod, I can see that the blue rod is split into 9 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this becomes my denominator. As we've said, it tells us how many equal parts there are in total. The yellow rod is worth 5 of these. 1, 2, 3, 4, 5. So if we're writing the value of the yellow rod as a fraction, it would be 5/9. What's the value of the red rod? Tell me. Good. What was your denominator? Y. Yes, good. 9. And your numerator? Excellent. That was easy, wasn't it? OK. But what is the value now of the yellow rod and the red rod together? And how can we write that calculation as a fraction? So you've already told me the fraction of the yellow rod. Tell me. Good. 5/9. 5/9. And the red rod? Good. So we're going to add them now together. 7/9 plus 2/9. What does that equal? That's right. Can you tell me the numerator? Good. 7. What about the denominator? Good. We still have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That hasn't changed. OK, let's take a look at this now. So we have our whole, and here we have the red rod. What's the value of the red rod? 2/9. Excellent. And what about the yellow rod? Yeah, 5/9. And what's the value of both of them together? Good. 7/9. So when we added the fractions, 5/9 and 2/9, did the order matter? No. Why? Good, because the value didn't change. The red rod was still 2/9 and the yellow rod was still 5/9. That didn't change. So the order in which we put them in doesn't matter when we're adding. So what kind of calculations do these models represent? If we have 5/9 and 2/9, what will the value of the black bar be? Let's take a look. 5/9 plus 2/9 equals 7/9. Good, what about this one? Say it with me. 2/9 plus 5/9 equals, good, 7/9, excellent. Now how do I represent these models as fractions? So here we know that we have the black rod, which is 7/9, and the yellow rod that is worth 5/9. How do we calculate the value of the red rod? Good, we start with the value of the black one, which is 7/9. Now what do we do? Tell me. Well done. Yes, we subtract what? Shout it out. Good, 5/9, and that's equal to, good, you've really got the hang of this. Okay, the next one. Let's take a look at this one. How are we going to represent this as fractions? Tell me the first fraction. Well remembered, yes, the black rod, which is worth 7/9. And now are we adding or subtracting? Good, subtracting what? Shout it out. 2/9, excellent, and that's worth, brilliant, 5/9. What do you notice here? Does the order matter? Yes, it does, doesn't it? So we always start with the, well, this isn't a whole, but the larger fraction, 7/9, and then we subtract the part. Okay, although I don't know if you've noticed, it's still the same three fractions, 7/9, 5/9, and 2/9, but the order does matter when we are subtracting. Now this is called a fraction fact family, where we have three fractions and we can write them in different ways. So we have the 5/9 plus 2/9, and then we can swap these, 2/9 plus 5/9, and they will still give us the same answer, 7/9. And then we have two subtractions. We have 7/9 take away 2/9, and we have 7/9 take away 5/9. The answers are different, but we always start with the largest fraction, 7/9, when we're subtracting. And you'll notice that it's still the same three fractions. Yeah. Now, if we're looking at all of these fractions, what is the same and what is different? What do you notice is the same? Shout it out. Absolutely. So all of the denominators are exactly the same. It's 9. And what's different? The numerators. That's right. So the numerators change, but the denominator does not change. So for your first independent task, I would like you to write down all fact families for the following rods. So here we have 2 addition and 2 subtraction. When you've finished, unpause and we'll go through the answers. So welcome back. And how did you do? Let's take a look. You go. Here are the fact families for these 2 sets of rods. Pause and check your answers. Fantastic. Okay, let's go on to the next part. So this pizza has 8 slices. Bella eats 3 slices. Lara eats 2. What fraction of the pizza has been eaten and what fraction is left? Before we begin, I'd like you to remind me how I would write a whole as a fraction. How many slices of pizza do we have? Good. So tell me, shout it out, how would I write it as a whole? Good, well remembered, 8 eighths, because we have 8 slices in total, and we're talking about 8 slices. So let's take a look here. Can you tell me how to write in fractions, as a fraction, how many slices of pizza Bella ate? She ate 3 slices. How would I write that as a fraction? Good, 3 eighths. And now Lara, good, 2 eighths. Now, if I wanted to find out how much in total had been eaten, I need to add it. Good, so tell me what the numerator is going to be. Excellent. What about the denominator? Well remembered. Good job. Yes, our denominator doesn't change. It still stays the same. Oh, sorry. Whoops. Now I need to calculate what fraction is left. And let me start with a whole. Remind me how to write a whole as a fraction. Good, 8/8. Now, am I going to add or subtract if I need to find out how many is left? Good, I'm going to subtract what? That's right. How many slices in total were eaten, which was 5/8. Good. So my answer, my numerator is going to be 8 take away 5, which equals 3. Good. And my denominator doesn't change. Excellent. So 3/8 was left. What problem could this bar model represent? Take a look. I've got a number line here and the value is 1. On one side I have it's divided into 4 equal parts. At the top it's split into 8 equal parts. What could it represent? Have a think and come back. Have you thought about it? Yes, you're right. What could this blue bar represent? Yeah, excellent. It could represent the whole pizza because it had 8 slices in total. We can see that 1, 2, 3, 4, 5, 6, 7, 8. There are 8 equal parts. What could the red bar represent? 1, 2, 3. Yeah, that's right. It represents what Bella ate. Great. What about the yellow bar? What could that represent? 1, 2. Excellent. It could represent what Lara ate. What about this blank bar, this white one? What could that represent? Yes, what was left? The amount of pizza left. Fantastic. Let's just go through wholes and fractions now. If this whole was equal to 4 quarters, how many quarters would there be in 2 wholes? And how would I calculate that? Tell me. Well remembered, good. So I'm going to multiply my denominator 4 by the whole, which gives me 8. Fantastic. Now I know that 2 equals 8 quarters. I have 6 quarters here. What could my missing number be? Yeah, absolutely. So 8 plus what equals, 6 plus what equals 2? 6 plus what equals 8? Sorry, I have told you the answer 2. Well done. Now let's take a look at this one. Which of these fractions, when added together, make 3? Now I have a mixed number here, I have a mixed number here. I have an improper fraction here, and then I have a mixed number here. So let me see. How would I convert this to a mixed number? Yeah, I would divide the numerator 6 by the denominator. So 6 divided by 3 equals, good, 2. Great. So I now know that that's worth 2. Now let's see which 2 fractions, when added together, make 3. So I have 1 here, 1 whole, and this is 2. So that I know that already makes 3. 2 plus 1 equals 3. And then I've got 1/3 and 2/3. And that would make a whole. So that would give me 4. So I know that I wouldn't add those 2. 1 plus 2 is 3 plus 1/3. So that's over 3. 1 plus 1 equals 2. 2/3 plus 1/3 equals a whole. So 2 plus another whole equals 3. So yeah, it would be these 2 fractions. Great. Okay, so this is now your independent task. There are 6 questions in total. I would like you to write them out. Pause the video and then continue on to questions 4, 5 and 6, and then unpause and we'll go through the answers. These are questions 1 and 3 and 4, 5 and 6. Great, are you ready? Okay, let's go. Number 1, the answer is 8/8, or you can also write 1 whole. Number 2 is 4/7, 1, 2, 3, 4. This is 3/6, and we can check that because 5 take away 3 equals 2. Next, we know that 1 whole here is, we look at the denominator, 10/10. So 6 plus 4 equals 10. The answer is 6/10. I hope you look very carefully here because we have a plus and minus subtract. So 4 plus 5 equals 9. And then 9 take away 2 equals 7. So the answer is 7/9. Here we know that our denominator is 7. If I were to convert this to an improper fraction, 7 times 2 equals 14 plus 1 equals 15. So as long as these 3 numbers add up to 15, then your answer is correct. If they do not add up to 15, then your answer is incorrect. They need to all add up to 15. Great. Let's continue. Travis baked a cake and cut it into 6 slices. He served Aldine 2 slices, Chloe 1 slice, and ate 1 himself. How much cake was eaten and how much remained? So let's take a look. First of all, I need to know the value of 1 cake. How are we going to calculate that? How can we see that? Okay, good. You noticed it said 6 slices. So that tells us how many slices we have in total. It tells us that there are 6 equal parts. So our denominator is going to be 6. Great. So a whole would be, excellent, 6/6. Fantastic. Okay, let's write these in fractions. Let's write how many slices Aldine ate as a fraction. He ate 2 slices. What's our denominator going to be? 6, good. And how many slices did he eat? Fantastic. So our fraction's going to be, good, 2/6. What about Chloe? She ate 1 slice. Tell me the fraction. Good, 1/6. And what about Travis? He ate 1 himself. Good, 1/6. Great. So if I now want to know how many slices were eaten in total, what must I do with these 3 fractions? Tell me. Excellent. Yes, I've got to add them. Brilliant. So 2 plus 1 equals 3 plus 1 equals 4/6. Brilliant. So I know that 4/6 of the cake was eaten. How much remained? So let's see. I have how many? I have 6/6. Great. That's my whole. And how many was eaten? How many slices were eaten? And how would I write that as a fraction? Good, 4/6. So am I going to add or am I going to subtract? Good, I'm going to subtract 4/6, which equal 2/6. Brilliant. If I were to write that as a bar, I would have 2, 4. Those are my 6 slices. Oh, this is how many Aldine had. He had 1, 2. This is how many Chloe had. Oh gosh, sorry. Let's do that again. She had 1. And then Travis had 1 as well. So this is how I would represent that as a bar. Now, if I was looking for the missing slices, this would be it. Okay. Great. Now let's take a look at this one. Mr. Murphy bought a 800 milliliter bottle of water. Okay, so I'm going to draw 800 milliliters. 1 square is going to signify 100 milliliters. So that's 100, 200, 300, 400, 500, 600, 700, 800. Okay, so I've got 8 squares. Great. He drank 200. So that would be 1, 2. So he drank 200 at 9 o'clock and then another 300 at 10 o'clock. So I'm going to draw another 1, 2, 3. Okay. Now, Miss Smeltzer said that he drank half of his water. Is she correct? Now I know just by looking at my bar that half of 800 is 400. 1, 2, 3, 4. So I know that half is here. But let me represent this as a fraction. How would I write 800 as a whole? Good. 800 over 800. How would I write 200 milliliters as a fraction? Yeah, absolutely. 200 over 800. And how would I write 300 milliliters as a fraction? Good, 300 over 800. So if I were to add them together, 200 plus 300 equals, good, 500, and my denominator stays the same, it would be good. These are really large numbers though. I was wondering, do you think we could simplify them? Yes, great. So what number could I divide 500 and 800 by? 100, absolutely, and that's really simple. 500 divided by 100 equals 5. And 800 divided by 8 equals, good. Okay, let's take a look. I still don't know though how much half is worth. So I'm going to write half. I know that 1/2 is written 1 divided by 2, or 1 over 2. And I need to find an equivalent fraction. So I know that I have 800 here. Now, what I need to do is to find, what do I do to 2 to get 800? Tell me. Yeah, I need to multiply 2 by 400. Absolutely, 400. So whatever I do to the bottom, I must also do to the top. So I'm now going to multiply 1 by 400. Excellent. So now my answer is, yeah, 400 over 800. Again, that's really, really big number. Can I simplify that? Absolutely. 400 divided by 100 equals 4, and 800 divided by 100 equals 8. So I know that this is half. The question is, Miss Meltzer says that he drank half of his water. Now we know that he drank 5/8. Is it the same as 4/8? No, it's more. So is she correct? No, she is not. We can also take a look at our bar to see that he drank this much more than half. Okay. I'd like you now to continue with your independent work. You have question 7, question 8, and question 9 to continue with. You can pause or go back and answer the questions, and then when you've finished, we'll go over the answers. Have you finished? Great, let's take a look. So the answer to question 7A, is 2/10. The answer to question B is 8/10. For number 8A, the answer is 3/9. B is 6/9. The answer to question 9 is 2/7. And the answer to question 10 is 5/8. And the answer to question 11 is 3/8. How did you do? Don't forget to tick or cross your work and then upload it onto Seesaw. We look forward to seeing your answers. I hope you enjoyed that. I'll see you again tomorrow. Have a lovely evening. Bye.